For any assignment-related queries, call us at +1 678 648 4277. You can mail us at support@solidworks.com or reach us at https://www.solidworksassignmenthelp.com. Problem -1. A clamped-free column is loaded at its tip by a load P. The issue here is to find the critical buckling load. A. Suggest a simple form of the buckled of the column, satisfying kinematic boundary conditions. B. Use the Rayleigh-Ritz quotient to find the approximate value of the buckling load. C. Come up with another buckling shape which would give you a lower value for the buckling load. D. Find the exact solution of the problem and show the convergence of the approximate solution to the exact solution. Follow the example of a pin-pin column, which is presented in the notes of Lecture 9. SolidWorksAssignmentHelp.com. Solution -1a. Kinematic boundary condition in term of shape function x for a clamped-free column is 0 equals 0 equals 0. Choose a buckling shape. X equals x2, x equals 2x, x equals 2x. SolidWorksAssignmentHelp.com. B. Use Rayleigh-Ritz quotient. The critical buckling load is. C. Choose a buckling shape similar to a cantilever beam. SolidWorksAssignmentHelp.com. Compare to the result in B. Na equals, this buckling shape gives a lower value. SolidWorksAssignmentHelp.com. D. Choose buckling shape. SolidWorksAssignmentHelp.com. Check for local equilibrium of the solution. This is the exact solution to the clamped-free buckling. Problem -2. Consider a clamped-free column loaded by a compressive force at the free end. SolidWorksAssignmentHelp.com. A. Determine the critical slenderness ratio distinguishing between the elastic and plastic buckling response. What is the buckling stress and strain? B. Calculate the critical plastic buckling load for E 0.5 ecrit and the corresponding stress and strain. C. Calculate the critical elastic buckling load for E 2 ecrit and the corresponding stress and strain. D. Compare all three results. Solution -2. A. First, find the bending load for clamped-free column. Second, find the buckling stress and strain. Recall that. SolidWorksAssignmentHelp.com. Then. Recall that. SolidWorksAssignmentHelp.com. B. E 0.5 ecrit, the column yields plus hits plastic buckling. SolidWorksAssignmentHelp.com. C. The column will buckle elastically. D. Compare the three results. Epsilon yield epsilon y elastic buckling plastic buckling. SolidWorksAssignmentHelp.com. To simply our comparison, assume n 0.2, e to 0.5 e, asterisk, and recall. Asterisk, in order to compare plastic buckling to elastic plus yield, we need to make future assumption about the material properties. Problem -3. Consider the pin-pin column. A. Suggest polynomial buckling shape function x to improve the approximate solution derived in lecture note. Note that the one used in class was the parabolic shape. B. Determine the accuracy relative to the exact solution. SolidWorksAssignmentHelp.com. Solution -3. A. The exact solution is W equals sin. Use the non-dimensioned value. The Taylor series expansion is so we know the shape function must be. For 0 less than or equal to x less than or equal to L/2, the boundary conditions are. The first boundary condition. This doesn't help. The second boundary condition gives. Solidworks assignment help.com. So we can us the Rayleigh-Ritz quotient. Solidworks assignment help.com. Since we have considered the shape function for 0 dx dl2, we must adjust the limits on the integral. Solidworks assignment help.com. B. The result are compared with the polynomial used in class and the exact solution. Notice how we significantly reduce the error by including a higher order term. Problem -4. Present a step-by-step derivation of the buckling solution of the pin-clamped column from the local equilibrium equation. Solidworks assignment help.com. Solution -4. Boundary condition for this problem. Start with fourth order ODE. We have an eigenvalue problem. Solidworks assignment help.com. Use the boundary conditions to solve for constants C1, C2, C3, and C4. Solidworks assignment help.com. Substitute C1, C2 into the above expression. So the equation to solve in order to find PCR is 10 KL 0. Solidworks assignment help.com. The smallest roots are KL equals 0 and KL equals 4.49. We choose KL equals 4.49. Problem -5. A. Derive the solution for an imperfect clamped A. Derive the solution for an imperfect clamped free column, like that considered in problem 9-1, following a similar derivation given in the notes for a pin-pin column in the notes. B. Find the ratio of current deflection amplitude to the amplitude of the initial imperfection such that the resulting load is 80% of the theoretical buckling load of a perfect column. Solidworks assignment help.com. Solution -5. WX, shape of initial imperfection WX, actual buckled shape WX, amplitude of initial imperfection W, end amplitude of actual imperfection. A. Moment equilibrium of imperfect column, perfect column. Assume that the initial imperfection is in the same shape as the buckling shaper. From boundary conditions Solidworks assignment help.com. From moment equilibrium of imperfect column. Perfect column. Imperfect column. Solidworks assignment help.com. Problem -6. The pin-pin elastic column of length L, shown below, is an I-section can buckle in either plane. A. Determine the buckling load in terms of L, B1, B2, T and E, assume that TB. B. What should the ratio of B1/B2 be in order for the probability of buckling in either of the buckling planes to be the same? Bonus. What could happen for very large width to thickness ratio? Solidworks assignment help.com. Solution -6. A. The moment S of inertia for an I-shaped cross-section is. Solidworks assignment help.com. If IYYIZZ, the column will buckle in XZ plane. If IYYIZZ, the column will buckle in XY plane B. For the probability of buckling in either of the planes to be the same, we want. The only physical solution is C, if B1. T, B2. T, then local plate buckling might develop. Solidworks assignment help.com.